Let's say you had this problem in front of you. Okay, so I'm just going to do a little bit of review through some power rule problems. We got to get those. Got to get the basics down first. So if you guys can copy this down and walk through the steps. So here are the power rule conditions. So I'm gonna have you guys kind of trade off telling me what you think the steps are. All right, so Daniel, what do you see that we can do here to get it ready for power rule? So how would you rewrite all these roots here?
Squared minus 5x minus.
Right. What's this in terms of a rational exponent? 7/2. Okay, good. Minus x to the what?
What do we x to the x to the second half.
Okay. So how does this 4 factor into it? Is the 4 going to show up in the exponents? Okay, it does. Okay, it does show up. Right. So think about square root of x, right? What's the square root of x? Okay. So do you know where the 1 and 2 are coming from? Why is it 1/2? Right, but these numbers are hidden in this diagram. Do you know what number? Do you know where the 1 is located and where the 2 is located? Yeah. There we go. Yeah. So what do you think this is going to be? Yeah. So if you don't see a number to the right, it's 4. If you don't see a number to the left, it's a 2. That's how it's a 7/2, and that's how it's 1/4. And the denominator is 7x to the 1/2. All right, so we're going to continue cleaning up. So Thomas, I think the cleanest way to go about doing this is
You make it the exponent negative on the bottom. Bring it up.
Yes, you can do that, but the 7 is going to have to stay.
So you also bring it up and make it like 1/7.
Yes. Yep. Yep. Good. So I'm going to pull that 1/7 out in front. Okay. All right. Does this step make sense, Daniel? Okay. So what would you do next to merge it all together? And how do we distribute this through? How do we combine those numbers together? So 2 minus 1/2 gives us what? 7/2 minus 1/2. 6/2, which is 3. And then 1/4 minus 1/2.
-1.
-1/4, yeah. Got to distribute that 7 through as well, so make it 3/7. Okay, so all of our conditions are accounted for. We can do power rule. So how would you do power rule? Thomas, can you do the first one?
Basically, you put like 5 or extra 5/2 divided by 5/2. And then do the same thing for the rest of them.
There we go. Yeah. Danny, can you tell me the last one? What's the last one going to be? What's the last one going to be? Power rule.
X
Mm-hmm.
to the 3/4.
Okay. What do we add to this?
1.
1.
To 5/2.
Okay. We can flip all these fractions up, right? 3/7 times 2/5, so I get 6/35, 5/28, and then 4/35.
Mr. What do we do for
Plus C.
PCT anymore? It's like,
Are you a senior? You're senior, right?
yes, I just do nothing.
Yeah. So don't come to school.
Like no school.
No school.
So it's like
My teacher said it's like asynchronous and like certain teachers might give stuff, but like it's mostly just notes and whatever.
I'm just going to have students just continue practicing with the previous. I'm not going to give an additional assignment. Just work on the previous ones. Okay. So this is all review, right? This is all review here. Okay. Now we're going to talk about U-substitution, which is something new, right? Which is what we've been doing since last Friday. So let's try this one here. So if you look at this problem here, okay, we always want to explore power rule. So how would power rule, or can we handle this problem using power rule? What do you guys think, Daniel, Thomas?
I don't know.
We can like expand.
Mm-hmm. But what's not ideal for expansion? Or what makes expansion an issue on this problem? I mean, we can do it, but
Have more factors or something.
not more factors. But do you think this is hard to do? 4 minus x cubed to the 5th? What do you think? Or if you wanted to expand this, do you know how to expand the 4 minus x cubed to the 5th?
We could just like multiply the 4 minus x cubed like 5 minus 5 minus.
Yeah, so it's 5 times, right? That's a lot of work, right? And this course, you're not going to have a lot of algebraic messiness, not to this extent. So when we see a problem like this, we always want to consider that maybe power rule is the way to go, but we should be able to recognize when power rule is not going to be the most efficient way. Okay. So our next option is this idea of U-substitution, okay? The idea of U-substitution is we're able to make this process a little cleaner, okay? So we'll let the U value be what's inside the parentheses here. Okay. So here's our U value. And what we're trying to do is we're trying to get this to look like this, everything from X to be converted in terms of U. Okay, so what's the derivative? What's the derivative of 4 minus x cubed? Thomas?
Like integral or whatever.
Derivative.
Yeah, okay, so
Like first semester.
negative 3x.
3x squared, right? Okay. Now we're going to cross multiply because we want to solve for dx. So I want to replace this, and I want to replace this. I want to get dx by itself. So when I cross multiply, I move the dx up. Okay, so Daniel, how can I solve for dx? Or how would you get dx by itself? Mm-hmm. So let's make our substitution. Okay, what can I replace the 4 minus x cubed with? What do you think, Thomas? What can I replace the 4 minus x cubed with?
I don't know, what would you do?
Is there something that is also equal to 4 minus x cubed?
I don't know.
Okay. How about you?
Wait, is it negative? Wait.
Do you see a substitution that I can make here? I can replace that 4 minus x cubed.
The negative 3x squared derivative?
Well, the negative 3x squared, that's going to come later. But for now, we're just going to find a substitution for 4 minus x cubed. Yeah. Don't forget the fifth power, right? Okay. All right, so Daniel, what can I replace dx with? Mm-hmm. Yeah, yeah. Now we want all the x's to go away, so do all the x's go away? Or can we get the x's to go away? What do you see?
You could, no, wait. Yeah, you could dx with it.
Well, we're done with the dx, so we're done with this. We're getting closer to our goal, right? Our goal is everything in terms of u.
Derivative of u, you can make 4u or 5u with x4.
Yeah, not yet, not yet. We're not going to do anything derivative. We want to get this cleaned up. We want the x's to go away. So do you see the x's going away here?
Then you can just make it negative 3, take out the x squared.
Mm-hmm.
All the
So this x squared and this x squared can go away, right? Because one's in the numerator, one's in the denominator. All right. Okay. So if I cancel those out, what's left?
Power 5 times du over negative 3.
And where can I put this negative 3 so that
You can make it like negative 1/3.
there we go, right? So do you see how nicely this matches? Now we can do power rule in terms of u. Okay. So let me ask you, Daniel, what is it about this problem at the beginning that allows for such a clean canceling out? Do you see anything in the beginning that will hint to the fact that we're able to just get the x squared to cancel out? What do you notice about the exponent? Okay, what about the degrees?
Oh, one is like first divided by
Say it again?
Isn't it like how the 4 minus x cubed is like when you do the derivative?
Yep, that's it. That's exactly it. You when your degree is 1 more than the non-u value, that's a good sign, because as soon as you find the derivative, that exponent is going to drop by 1, and once it drops by 1, it's able to match and cancel out. So usually that's a good sign, right? If you can see that relationship at the beginning, you can kind of think ahead and realize things will work out. Okay. So once we're here, now we can find a power rule, right? So Thomas, what's the antiderivative here?
U6, U power 6 over 6.
Plus c.
U6, is that it?
Yeah. Okay. How would I clean this up? Just multiply this, right?
1/3 out 6 equals.
Yeah.
Yeah.
Yeah. And then our final step is, this is, remember, u is just a temporary variable. So how can I bring it back? What's my answer going to be? Yeah. Okay. So I'm going to give you a similar problem. Have you try it, and I want to see if you can follow these steps. Okay. So I'll leave this on the board, but here is the problem that you're going to try. So this is x cubed. The cubed is separate, x cubed, and then square root of 2 minus 3x to the 4th. All right, so try that. See if you can. Here's your example. Let me see how you guys do.
So,
Okay.
so did you get u equals f for minus x to the power 3 in that one?
The way we know is whatever is inside the parentheses is your u value.
Okay. So you have u equals square root 2 minus 3x.
Except the square root is not ready, right? So can I rewrite the problem?
Yeah, you put the 1 over 2 over.
Okay, there's your u value, and there's your substitution there. Okay, what's next? All right. Okay. What happens after we find our u value? Find the what? Derivative, right? Du dx. Okay, what's du over dx?
12 x to the power 3.
Cross multiply. Solve for dx, because I want dx to be replaced, so I want to find a substitution for it. Mm-hmm. Substitute. Okay, what's next? Can I clean things up here? Can we rewrite this problem to make it match our power rule a little better? What looks like it's standing out that we can rearrange? What makes this not quite look like this yet? This side here, just left side. I'm trying to make this look like the left side.
Right now. Oh no. What's wrong with it?
Well, do you see a number that seems out of place?
This is negative 12x.
Yeah, well, the x is gone, right? So that negative 12, where do you want to put it?
So,
Does it come up?
negative 1 over 12.
Yeah. So now this is clean, right? See how clean that is? Once I get past the coefficient, it's matching perfectly with power rule. So now I can do power rule. Okay. What's my new exponent?
Um, 3 over 2.
Hmm. Flip the fraction. The 2's cancel out. We're left with negative 1/3. And then what do we do with the u? In terms of x, right? Okay. Let's see. Shido, Tam, do you guys have any questions?
I don't have any questions.
Okay. All right, let me do one where we have to involve a trig rule. So on your formula sheet, you're going to have these trig rules that we have to be able to match and use. Okay. So let me show you one here. Now this looks complicated, right? But does this resemble any rule that you see in front of you?
Second one.
Yeah, secant 1. So eventually, right? But we can't make it tan u plus c until we've gotten this to look exactly like this. So, right, so we have all these things that are sticking out of place that we have to resolve, right? So we got to go through U-substitution. So what do you think our u value is? 5x cubed. Okay, so what's the derivative? What's du dx? Cross multiply? Cross multiply? Okay. Divide both sides by 15x squared. Let me underline the parts. Make my substitutions. All right, do you guys see how I worked my way down, and piece by piece I'm getting everything in terms of u? Because that's my goal, right? I need my problem to look virtually the same as this. I may have a coefficient that's different, but after that, it needs to look exactly like it. Okay, what do you guys see here? Does anything go away? Does anything get moved? What else? I'm pretty close now, right? How can I get it so that I can make it look like that? Easier. Can I just push all the things out in front that's not part of this coefficient? So what's my coefficient? What number can I put in front? And? Okay, so how would you rewrite? How would you write that? How would you involve the 2 and 15 out in front? Oh, like 30? Well, the one's in the numerator, the other's in the denominator. So just divide it, right? So 2 over 15 doesn't divide evenly, so just put it out as a fraction in front. And what does secant squared u turn into? 10u. And then, is this our final answer? Okay. What's our final answer then? Yeah, so whenever we think we have our answer, we got to bring our u back in terms of x. Okay. All right, let's try this one here. Change this a bit. All right, how about this one here? 3x cosecant x squared, cotangent x squared dx. Does it look like a rule that we can use? Yeah. So what do you think our u value is going to be? Are things going to work out where the x's will cancel out? What do you think? Okay, why?
Because the derivative of
We'll produce an x and that will cancel this out. Yeah. Okay, cross multiply. Divide both sides by 2x. Make our substitutions. Okay. Do you see the rule kind of forming its shape here? Okay, what can we do next? But we still got to keep track of the what? Which is? And are we ready to apply our rule here? Yeah. Cosecant cotangent becomes
negative.
Yeah.
Plug in your u.
Yeah. Place the u back in terms of x, right? Okay, questions? So yeah, I'll probably have help sessions every afternoon to kind of go over what we did in class. So, all right, Ishida, Tam, do you have any questions?
No, I don't understand.
Yeah, I don't have any questions either.
Okay, all right, so I'll have a help session Wednesday afternoon as well. If you want to come back and get some more practice, feel free to do so.
Okay, thank you.
All right, take care, guys. Have a good
Thank
day. Bye.